All right, it says the table above gives values of a differentiable function f and its derivative at select values of x. That's weird, okay? If that doesn't make you feel a little uncomfortable, it should, because it's kind of weird. You probably haven't seen something like that before. Okay, if h is the function given by h of x is equal to f of 2x, which of the following statements must be true? Okay, so we're going to break this down bit by bit here. There is so many moving parts to this. So let's look at this first one, Roman numeral 1. H is increasing on the interval from 2 to 4 here. Okay, so if h is increasing, that means its derivative is positive for every single value between 2 and 4. Okay, you don't really, well, maybe you do need it later on. You don't need it for this problem necessarily, but I'm actually going to find h prime of x really quick. It's the derivative of f of 2 of x. So it's going to be f prime of 2 of x. We're just using chain rule here. That's the derivative of the outside layer, f prime, times the derivative of the inner layer, which is 2. So that's what h prime is. Now, we don't actually know what's going on between 2 and 4. We know what's going on at 2 and at 4, but we don't know what's going on in between. So if you notice right here, it says which of the following must be true. That means you can't think of any possibility to make it false. Okay, there is no such thing as a possibility to make it false. This one, there is possibilities because we don't know what's going on between 2 and 4. What if at x equals 3, the derivative is negative? Okay, f prime is negative. Well, f prime is needed for this h of x. So let's just say if I put in like 1.5 in for, or if I put in any number, really, it wouldn't matter. You don't know what the sign of it's going to be. Is it going to be positive? Is it going to be negative? So because of that, you can't actually include Roman numeral 1. Because if you can think of one possibility where it's false, it must be true. Okay. The next one, there exists C between 0 and 4 such that h of C is equal to 12. Okay, this doesn't say it in this problem, but you need to kind of see that that's really just saying mean value theorem. There exists some value C between 0 and 4 such that h of C is equal to 12. Okay. Actually, this isn't mean value theorem. I take that back because it's not a derivative. 3 is mean value theorem. What theorem is number 2, Roman numeral 2 here? It is a theorem we've gone over. There's no derivative in this. It's just an algebra theorem, really, but we cover it in calc. Come on, someone's got to know this. This is all positive, so I'm just going to keep it like this. All right, well, when in doubt, graph it out. Hopefully by graphing it, this will make a little bit more sense. So what I'm going to do, 0 to 4. So if C is 0, let's just say X is 0 on that. F is 3. So I'm going to put a 3 here. Okay. At 4, let's just say 4 here. The F is 9. But I just realized I'm doing this in a silly way because I'm using F instead of H. It's embarrassing. Okay, we want to find H of 0, and we want to find H of 4. By the way, me messing up like this, like you are going to do that as well. Like get used to kind of like trying to figure this stuff out, okay? Because it's not just like a standard problem. It's a lot of figuring things out. So H of 0, well, H is equal to F of 2 of X. So this is equal to F of 0, F of 2 times 0. Well, F of 0 is 3, so I guess I could have kept that 3 there. Put it right here. Okay, so that's H of 0 right there. H of 4 is going to be equal to F of 8, okay, because the X is 4, and you did 2 times 4, so it's 8. F of 8 is in the table, that's 13. Okay, so H of 4 is 13. Okay, now it says that the function f is differentiable. So if it's differentiable, that also means that it's continuous. So what I'm going to do is kind of just make a little continuous function here, and you're legally allowed to do that. Before, you can't just make a function because it doesn't necessarily say that it's differentiable or continuous. This one says it's differentiable, so you can make that function. And it's saying is there some value between 0 and 4? So on this interval, is there some number in between where it's equal to 12? And your answer would be yes. Okay, what theorem is that where there's some number in between? I'm sure someone's writing in the chat, but I'm not hearing the thing. So if you are writing in the chat, I apologize. Does anyone remember it starts with an I? The second letter starts with a V. It rhymes with, it's intermediate value theorem, okay, IVT. This means there's a value in between. And the value is in between because if it's continuous, there is going to be something in between. That's what continuous means. Okay, so if it goes from 3 to 13 for the y and it's continuous, there's every number in between 3 and 13. There's zero calculus in that, okay, zero. There's no limits, there's no derivatives, there's no antiderivative. It's just algebra. But that one is true. And it has to be true because intermediate value theorem states that it is. It's continuous, so there has to be something between 3 and 13, including 12, because 12 is between 3 and 13. And probably super easy after I word it a different way and graph it out, but to get that the first time is difficult, in my opinion. So because Roman numeral 2 will work, we can get rid of all the ones that don't have a Roman numeral 2 in it. Probably a smart thing to do. All right, Roman numeral 3, there exists C between 0 and 2 such that the derivative at C is equal to 3. That's mean value theorem. So we have an intermediate value theorem, and then we have a mean value theorem. So we need to use mean value theorem to see if this is actually true, okay? Intermediate value theorem states that the average rate of change has to equal the instantaneous rate of change. You know, there's some point that has that same slope of a point, has the same slope as the slope of the endpoints. Okay, so if we were using this as an example, we can actually use this graph. Nope, I lied because we're going to 2. Darn it. So now I have to regraph this. Hold on one second. So I'm going to regraph this just to get an idea of what's going on. All right, so we're going to 2. So let me rewrite this. So we're doing h prime of C should be equal to the slope from 2 to 0. And that's just the slope formula on this right side. Okay. The thing is, we need to figure out what is the slope of the endpoints here. So h of 2 is going to be equal to f of 4. Okay. So h of 2 is equal. H of 2 is equal to f of 4, which is equal to, if you look at the table up there, f of 4 is 9. Okay, h of 0 is equal to f of 0, which is equal to 3, because we found that before. So now we can use this formula right here. So we're going to do 9 minus 3 over 2. You get 3 out of this, which, okay, so this is true. So 3 actually does work because if you do intermediate value theorem, it does state that there is a point where that's equal to 3. And if you were actually to graph this out, you can graph it out like this. This would be 9. That goes right there. At 0, it's 3. So that's right here. Okay, now we don't know what the graph looks like here, so I'm just going to make one up. But if you notice, I can find a slope between these 2 points right here. And is there another point that has the same slope? Yes, there's 4 for that example that I made. In fact, it's impossible to make any graph that doesn't have that. That's as long as it's continuous and differentiable. Okay, so what I mean by that is let's just make the line first. Okay, that's the slope of the endpoints right there. It is impossible to make any graph where it will not have that same tangent line. So say I did this, whoop, same tangent line right there. Okay, well, what happens if I just did a straight shot? Well, now they're all the same slopes. They're all the same tangent lines there. No matter what you do, say I just go up and down on this, nope, it's still one there and still one there. Okay, you cannot break mean value theorem.